Hi, this is Anthony Pedone for a series called SQL in 10 minutes. We will discuss various topics within the 10-minute time range. And let's get started on something called resource governance. Okay. So, resource governance is a design pattern to allot the use of resources to the current demand. It's a pattern that's used a lot in the cloud, and it's used on on-prem or anywhere else actually, where resources are allotted out to the demands at that particular time. So we broke this study down into tiers, components, and examples. And by the way, this is 10 minutes, so I'm going to set the timer right now for 10 minutes. Go. Okay, so we're going to look at the tiers of the resource pattern. And we'll just bring this up. It's coming now. And if we can, we'll just enlarge it a bit. Very good. So now we have two tiers. We have defined two tiers. There's the analysis tier, which is the pre-process tier, and then there's the process tier, which is the execution tier. Okay. And just for a quick verbiage here, the resource governance is essentially the provide adequate resource, whether capacity or performance, based on current demand. So during the analysis phase, there are a couple sections to that. There's a monitor collection. So there's collection of the resource usage at that particular time. Then there's processing requirements, and then evaluate capacity of the resources. So once we have all the accumulated information about the resources being used at a particular time, we check then the processing requirements, at what point do we reach a threshold, and we evaluate that through the process of capacity of the resources. Then it's shifted on to the process tier. From there, if it failed or passed rather, in that the thresholds was crossed, there was a crossing of the thresholds, resource governance is kicked in. Somehow the resources are allotted to the demand at particular times, and to not to allow the system to stall, overly stall at that particular moment. And then so there's a pre-process and a process, and then it continues on. So those are the basic tiers. If I may, let's get on to the components. The components are basically pretty much like tiers, but they're represented by actual threads, processing threads. So it's kind of repeated what we just said. I'll just enlarge that a bit also. As far as the processes, there's a collection process, there's a determination process, an adjustment process, and then an execution process. So the collection process is where we're collecting information about the runtime effect on all our resources, from the application, from the subscription or tenant, from the service, from IoT, Internet of Things. So there's a collection of information, and this is all through the telemetry or the instrumentation process, where it's collecting information, metrics, and logs. Then the resources are then monitored also to see if they pass their thresholds according to the collected information. If so, if we pass the threshold, a max limit was reached, resource governance will kick in. Now, resource governance is expressed in two particular ways. There's a throttling of requests, there's a throttling, and there's scaling of resources. Throttling is where the request is actually rejected, or it can be degraded. It can be put in a queue on priority basis. It could stall, or it could be deferred at a later time, the requests. The scaling is where you grow and shrink a resource, an elastic scale type. Essentially, that's mostly based around VMs, where the compute process is moved to, actually the compute process from another VM is then housing the execution process of your app. And so it's using those facilities. So there's a growing and shrinking, meaning that we're going to use and deploy a new VM. And here we're going to actually hold back the request so other people can share that particular request. Then it goes on to execution. Okay, now we'll end that there. Next thing we'll do is look at some examples of the resource governance in action. Again, we mentioned there was scaling and throttling. We'll look at scaling first, which is very quick. As I mentioned before, the deployment of scaling is essentially evolved around the compute process, meaning the VMs that house the CPU. There's more VMs created at that particular before execution time, and when we reach a threshold, the whole deployment or redeployment of the application is then shifted to that VM. That's the elastic part of it. And here's just a quick example. an Azure infrastructure, collection of information, or a time schedule. There's analysis, meaning a scaling engine is running. It decided that a threshold was met or a rule was met on the VMs. The VM was either scaled up, scaled down, therefore an allocated or deallocated deployment of an instance housing now your application. So that's just a quick understanding of the auto scale example of an elastic type atmosphere. The next one is the throttling. Just checking my time here. Throttling is essentially where we will hold back the request. We won't grow it. We won't grow a brand new VM. We will just hold back the request. I have two examples here. Example one has to do with the tenant. The tenant scoped within the Azure cloud. So this throttling within a multi-tenant system based on the rate limit. So this is very high-level scope throttling in the fact that based on the tenant system, we're throttling based on how many requests are coming in. So as we see here, 5 requests, 10 requests, 150 requests that reached the throttle point, and there was throttling involved. Throttling means now a new VM was then put up, deployed, and the application was moved over to that VM. I'm on a local note, say in SQL Server, I looked at memory grants. That's a throttling process also. It's kind of a load balancing and a throttling. If you look at this, SQL Server has 5 different queues for different requests based. The queues are based on the cost of the query. So a low cost query go into one, and we receive from there 2, 3, 4, 5. So they're actually load balanced against that. Next, those 5 then queues look at the shared memory and request memory. If there's enough memory for Q1 to run, it will run. If Q2 to run. So, but otherwise, they have to wait. They're actually queued up. As you can see, they throttle the queued as memory requests until the memory is available. So that's a process of throttling also. So throttling, which is one strategy. Scaling, which is then creating a new instance to house your new resource, your extended resource, is another strategy. It's a performance type pattern used extensively in the cloud, and so it has to become part of your monitoring process and your optimization process also, because that process can kick in, the throttling can kick in, the redeployment on a new VM can kick in, and your application will slow down. So you have to be aware of what's happening. Also, the engine that's doing the monitoring of the throttling and doing the monitoring for the VM scaling can also interfere with your workload. So we have to get involved in that too, as far as more performance tuning. I see that we ended it in less than 10 minutes. So again, that's resource governance, strategy-wise, broken down to throttling and scaling. And that ends this topic, and I hope you stay tuned for another one. Thank you very much, and have a good day.